All right, so in lesson 3.2, we're going to work on some power rules. So basically, this whole section or this whole lesson is going to be devoted to simplifying expressions using power rules. Now, there's a bunch of different power rules, but it all comes down to the idea that this exponent doing x to the fourth power is the same thing as taking x multiplied times itself 4 times, or 5 raised to the third power is 5 multiplied times itself 3 times. Now, the x and the 5 in that situation are called the base, and then the 4 and the 3 in both those situations, those are the exponents. So basically, exponents when you have whole positive numbers are the same as repeated multiplication. By the way, you're going to hear me say that x to the fourth is 4 factors of x. That just is saying x is multiplying by itself 4 times. So a factor means multiplying by. Specifically, the factor, a factor of something means how many times we've multiplied. So 4 factors of x is x to the fourth. Now, there's going to be a lot of different rules that we're going to deal with, but they all come back to this idea. So we're going to look at a bunch of different rules. And there is a asterisk around all of these rules, and the asterisk is that we assume the base is a non-zero number. Because if the base is actually 0, then we get some weird things. We don't get some weird things with this. For instance, if x was 0, 0 times itself 4 times is just 0. That would have been fine. But when we deal with negative exponents, when we deal with dividing, we don't want that base to be 0. So we want to be able to divide and those types of things. Now, you're going to see on the couple of pages, on the page here, a lot of different rules for how to deal with exponents. And I'm going to do these sort of one at a time. I'm going to look at a few of these rules and a few more and a few more and give you some examples. All right. And those examples will be beyond just what the cooperative group problems say. First rule that's listed out on page 126 is the product rule. It says if A is a real number and M and M are natural numbers, then A times M times A to the nth power, A to the mth power times A to the nth power is A to the M plus N. Now, you can see some examples here of how that product rule is being used, but this is actually probably the most important rule that we're going to have in terms of what we're going to do in the next section. So in the next section, we're going to start multiplying polynomials together, and a lot of times it involves the product rule. Let's take a look at a couple of the product rules. First off, we're going to look at why the product rule is the way it is, and then we're going to use the product rule to simplify some very common expressions here. So let's talk about why the product rule it is the way it is. So this says x to the fourth, and we know that is 4 factors of x multiplied times each other. So let me actually insert a dot every time for multiplication. I think that's going to make this a little bit easier. So we have 4 factors of x. That's x to the fourth. And then we're going to multiply times x to the fifth. So that's just 5 factors of x. I think I got 5 there. So if you'll notice, what we have here is 4 factors of x times an additional 5 factors of x. But when you combine all of those factors, you combine to get 9 factors of x. So we got 9 factors of x, and that's the reason why when you have the same base, so x to the 4th and x to the 5th, you can take that same base to the sum of the two exponents. So you multiply two numbers which are written in exponent form, and those two numbers have the same base. Then you can take that base and raise it to the sum of the two exponents. Now, knowing that, we don't have to write out all these factors of x every time, or all these factors of whatever variable we're using. Knowing that now, if I have s to the 8th times s to the 13th, all I have to do is say, well, 8 plus 13 is 21. So that's s to the 21st power. Now, you might ask, well, how does that work with when we have, instead of just a variable to a power, what if we have coefficients times variables? Well, in that situation, what we can use is the associative and commutative properties of multiplication. Remember what this signifies, this 3x to the 9th is 3 times x to the 9th. So what we have is 3 times x to the 9th, and then times 5, and that 5 is being multiplied times x to the 7th. All right. Commutativity and associativity of multiplication says that I can take this 5 and I can sort of pull it out front and say, well, actually, we wanted to do 3 times 5 in the front, and then multiply x to the 9th times x to the 7th. And so what we do there, 3 times 5 is 15. X to the 9th times x to the 7th, that's just our product rule. So that's going to be x to the 16th power. So notice that the coefficients multiplied, these numbers, when they multiplied, we had to add the exponents along that same base. Now, once you get good, once you've done that enough, then this becomes a fairly quick and straightforward process. 9x to the 13th times 13x to the 9th. The coefficients are going to be 9 times 13, which is going to give us 117. So coefficients multiply to give us 117. X to the 13th times x to the 9th. Well, 13 plus 9 is a 22. So it's 117 times x to the 22nd powers. Again, to the 22nd power. Again, notice that we took the 9 and the 13, multiplied them, and then in this case, x to the 13th times x to the 9th. When you multiply, you add those exponents because of the product rule. So that's the product rule in action. And like I said, that's the biggest one moving forward, because when we multiply polynomials, we're going to use that product rule and the product rule with coefficients over and over and over again. Now, the other rule, the second rule that this gives you is the power to power rule. Now, we're going to look at this in just a moment, but the power to power rule, we're going to look at an example in just a moment, says that if you take a to the m and you raise that whole number to the nth power, then you multiply you take a to the product of m times n powers. And you can see what happens here. X to the 3rd squared, you'd multiply 2 times 3 and get x to the 6th. Negative 3, x to the 3rd, y to the 5th. It turns out, because all of these things are multiplied, you can square each part. So you can square the negative 3 and get a 9. You can square the x to the 3rd and get x to the 6th. You can square y to the 5th and get y to the 10th. In fact, you can do that also not just when everything is multiplied, but also when everything is multiplied or divided. Now, this comes back to what I was saying earlier about that commutative and associative property of multiplication. So why this works, why we can do this power to power rule, is because of the commutative and associative properties of multiplying real numbers. Show you via an example of what's going on. Now we saw in the example earlier that what you would do is you would take 3 to the third power, then you take x to the fifth to the third power, then you take y squared to the third power. Now the reason why you can do that is, once again, the commutative associative properties. So this means take 3 times x to the fifth times y to the second, and we're going to multiply that whole thing by itself 3 times. So what you're going to do is you're going to take that whole thing multiplied times that same thing multiplied times that same thing. Let me clean that up just a little bit. And because multiplication of real numbers is commutative and associative, what I can do is and notice all of these symbols are multiply. So every single operation here I have is multiplication. So I can sort of move things around. I can take that times -3 and put it up in front. I can take this times -3 and put that up in front. I can take the x to the fifth and the other x to the fifth, put them together. I should have erased that one. Take the x to the fifth. So now what you see is 3 times 3 times 3, which is just 3 to the third power. So we get 3 to the third power, then x to the fifth times x to the fifth times x to the fifth. Notice that by my product rule, you just add 5 plus 5 plus 5 and get 15. I'm going to instead write that as x to the fifth to the third power, and then I'll do the power to power rule, 3 times 5, and then y squared, that's also being raised to the third power. And so when you calculate this, 3 times 3 times 3 is 27. X to the fifth to the third power is x to the 15th. Y squared to the third power is y to the 6th. So that's how that power to power rule works. Now, one thing to watch out for is negative signs. You can take a look at what's going on here, power to power rule. If we would have had a -3, make sure the negative sign gets squared or cubed or whatever it's getting raised to. Make sure the negative sign goes inside the parentheses so we don't throw things off. All right. So those are the two big rules, product rule and power to power rule. Now, one thing I want to say before I shut down this video is that this power to power rule does not work when I throw in a plus sign. If I were to throw in a plus sign, I can't rearrange things the way I want to, because while multiplication is commutative associative with itself, multiplication does not work really well with addition. You can't switch around addition and multiplication. For instance, if I said 3 times 4 plus 5, that is not the same as if I would have taken 3 plus 4 times 5, right? So we can't willy-nilly move the multiplication around, or the multiplication by 4. I can't say 3 plus 5 times 4. I can't move that 4 to the back. Does that make sense? So multiplication and addition don't commute. But when I just have multiplication, then this works just fine. Also, when I have division, this works just fine as well. So if I had 3x to the fourth, actually let's not take 3, we used 3 just a second ago, 2x to the fourth divided by y, and I raised that to the second power, well, it turns out division and multiplication are also commutative. So you can also, when you have division going on here, you can raise 2 to the second power, and that's going to remain in the numerator. X is going to be raised to the 8th power. Y is going to be raised to the 2nd power. So what we end up with is 4 to the 2nd is 4, x to the 8th over y to the 2nd. So again, multiplication and division work nicely with each other. You can move them around a little bit, or at least when you multiply two fractions, the way you do it is you multiply tops all like this, multiply bottoms all like this, and there you go. So when everything's multiplied, you can use that power to power rule. When everything's multiplied or divided, you can use the power to power rule. All right. But if you throw a plus sign or if you throw a minus sign in there, you cannot use that rule. All right. Now, whoops. We can do some of the problems on these instructor-led problems right now if you'd like. For instance, number 2 you can do, number 5 you can do. But we're going to look at the other rules in the next video, and then we're going to do all of the instructor-led problems all at once. All right. So we've done the two main ones, product rule and power to power rule. We'll do the next in the next video.